Cześć wszystkim obecnym. Myślę, że możemy zacząć. So, hello, because presentation will be in English, so that's a very important thing. And I will today speak a bit about the streams and stream gatherers, which are the great addition to the Java 24 onwards, which can simplify and solve some issues that we have already with the streams that we know all from the Java 8. So let's say a couple of sentences about me. My name is Kamil Banach. I am working with Java and web apps for at least 10 years, mostly with the Java environment. I am also a SaaS founder and Oracle ace. And if you want to talk with me, meet me, or spoke with me, or have any questions or something, you can grab this you can scan this QR code. It will point you to my site. And also you can always talk to me on the social media. There are a couple of them: Blue Sky, Mastodon, Twitter, or X, whatever the name currently is. And you can find it on the slide. So let's go to the main topic now about the streams. Let's take a look at this code. It's pretty simple. We have the 1, 2, 3, 4, 5, 6 or 7 lines of code. And the question is, what does that code do? Do you have an idea? Do you have an answer? Yes, exactly. It does nothing. And the question is why? The answer is pretty simple, because in the end, in the streams, we have two different operators. We have intermediate operators and terminal operators. And in the end, those intermediate operators are not executed in this pipeline of the stream until we finish the stream with some terminal operator. And we can, of course, we have multiple intermediate operations like filter, map to X, and so on. We have also a lot of different terminal operations: for each, collect, and of course reduce. We can use them to tailor the streams to our needs. But in the end, until let's say now, until the Java 24, the only place where we could extend the streams, make some custom code, make some custom operators, were collectors. So in the end, we have the streams. So we can filter, we put some data, we map them and collect, and only when collect we can get the results. And only we can write new terminal operators. New terminal operators using the collect interface. So this was the only one place where we were able and are able to extend the streams API. And we had some pretty nice interface to do it. So we have collector, TIR. Honestly, I do not know why all interfaces in Java have some short names for the generic. So TIR, it's kind to comprehend what does that mean. So we can look at them in some better description. We have the input, accumulator, and we have the output type of the collector. So now it's pretty understandable. So we have the collectors, we have the operations, we have this intermediate, we have the terminal operators. So we can go to some examples. So if you want to see the examples, to check them by yourself, you can scan the QR code available. It will redirect you to the GitHub with all examples from this presentation. Okay. Somebody else wants to scan? Nobody? Okay, nobody more. Let's go to the examples. So Let's start with the multiple steps. It is nice. Yes, it is visible. Yes, so as I said, the terminal operators are not executed before we have some terminal operators. So for example, we have two lists here, but we need to remember that the terminal operators are lazy, or at least streams are lazy. So if something is not needed to do, it will not be done. So for example, we have this list of strings, and we have some operators, so filter and map. We can expect that the step by step, by going to the next steps of the pipeline, will have less work to do. The stream will have less work to do. So let's run it. And we can see that we are processing the all words. We are checking the stream using peak. Remember, peak is only for the debugging purposes, no using in the production code. We'll go why in a couple of next slides. But we are processing all words, and we can see that we are filtering them and searching getting only the words that have the length longer than 5 characters. And we can see that the first word that is processed is banana. So we can see that it contains processing, so it's passed through this filter operation. The same, you can see that it's passed through the second filter operation, that it contains A, and is mapped to uppercase. And we can see that only a couple of the words, so 3 words, banana, orange, and race car, which fulfills 2 filters, are in the resulting array. So we can expect and we can see that the streams are lazy. We can also, besides of using the streams, using the operators, we can create the custom collectors, or at least use the collectors for various purposes. So, for example, we can use collector grouping by size to group those words by size. We can also use, for example, instead of using the string builder to build JSON array in the JSON style, we can use the collectors joining for it. And let's see it. So we have the pretty nice working code for it, and we can expect that this one, those three lines, works and looks pretty much better than the string builder example. We can also build the custom collector, and for sure you can see that you could see the examples of the collectors, which looks like this. So we have the anonymous class of the collector, which looks ugly. But instead of the anonymous class, we can use the shortcuts that are provided from the library. And for example, this collector here, which is only re-implementing the collectors to list in our custom code to a couple of lines. So we have the collector, we have the supplier. So what is the accumulator that we have in the collector? What we want to do to add new elements to this collector, so we are using the linked list add. How to merge 2 different elements, 2 different parts of the stream. For example, if we have the parallel stream. And information about characteristics. Characteristics describes our collectors if they are parallel, unordered, or have identity finish. Identity finish means that we are not doing at the end, before returning the result, we are not doing anything. It's the empty function there already. So we have here finisher function identity, and this means exactly the same. And those characteristics from the collectors are important, because if we go to the getterers, the new addition, we have the similar things like characteristics, but working, or at least they were defined a bit different. So we have covered, let's say, a lot of the things about the streams, about how they work, about collectors. But the question is if it is worth using them. I hope so, that you think it is usable, because let's look at this example. For example, I have this list of the multiple movies, and I want to calculate the average rating per January. So, for example, fantasy movies have this rating and so on, and we have to do it in the loops. We have to make two loops, and in case of the streams, we can do it in the one looking maybe at first a bit overwhelming, but pretty nice stream. So we are doing the flat map, so are we flattening the list of the genres per movie and making the map entry with the genre and the rating. So we have now a long list of the genre to the rating, and we are grouping these by key, so by genre. Yeah, so let's go back to the presentation, and what can go wrong with the streams? So we can see that they are pretty nice, working. We are happy to use it because it is functional programming and so on. But what we need to be aware. The most important thing, or maybe not the most, but the one that will break in the production, is that the exceptions makes boom. So in the end, if we have the streams, we need to be very careful in regards to to have the exceptions in our code, especially the runtime one, so non-checked exceptions, because in the end, any exception that we have in the stream will terminate this stream in the runtime. And on the other hand, we cannot use any method as a lambda, and in the lambda, so for example, you have the action that throws exception, so checked exception, this code will simply not compile. That's bad. So we need to always cover all exceptions. And the second thing is that the parallel streams are not as fast as they seem. So let's go back to the code. We have pretty nice example of parallel. We have some API action. Let's assume that is IO operation. We are calling some external API, maybe using HTTP. We can already see that we have the runtime exception thrown here, and we need to catch the interrupted exception. But if we want to run it and we want to parallelize those calls, what we can do? We could use parallel, but let's look at the normal sequential stream first. So it's running. We could expect that it will run for the 10 seconds, 10 operations per 10 operations per 1 second, sequential 10 seconds. So that's pretty obvious. But we want to be good programmers and want to make some improvements in the performance. So we will use parallel. And we'll run it now. And boom, we have we can see that it runs in 1 second. So that's perfect. We can now call ourselves performance engineers. Unfortunately, no. So let's, for example, make this from 10 to 20 calls, and let's run it again. we could expect that it will run again for the 1 second. And we can see that it ran for 2 seconds. Why? Do you have an idea why it runs for 10 operations it runs for 10 seconds, and for 20 it runs for 2 seconds? Yes, it is almost this. In the end, the streams are using underneath the common pool, and this common pool is based on the number of the threads that on the cores threads that we have in the on the hardware. My notebook has 8 cores, which everyone has 2 threads. So in the end, it has 16 cores, let's say. So if I change it to the 16, we could see that it will run in the second. And if we change it to the 17, it will run it for 2 seconds. So the 16 operation will run in the first second, and the one will wait for end of the all previous ones. So that's a pity. We can overcome this with some additional hacky solution, but it's not recommended. So we can, for example, run the stream in additional fork join pool, which will make this stream using the different fork join pool. So if I run it right now, so I have the fork join with 50 threads, and I will run for the 40 jobs. It will run as expected, so for 1 second, but this is something that can change. The information that the streams are using the fork join pool underneath and using the common pool is the implementation detail that can change, so it's not recommended. And this was the reason that the streams were not used commonly in the parallel version. Another thing that can bite us is the optimization of the pipeline. So in the end, the terminal operation determines if some operations are optimized out. And we can see on the screen that we have the pick operation on the left that will print the list of numbers. And if we run this code, it will not output any numbers, but only the count. So only the result of the stream. On the other hand, on the right, we can see that the same stream on the different stream, on the stream that is built in a different way, will be run. So it will be iterated, and every single number will be printed out. And the question is why? It is because the count operator, terminal operator, is having an optimization underneath. So the first thing that the terminal operator is checking if we know the size of the stream of the splitterator, and in case of the list, in the end array list, linked list, and so on, every list that is storing number of the elements, we have this number, so it's gathered straight away and returned. And in the stream generate, where we are generating infinite stream, we don't have this information. And what will happen if we will have the, for example, map or filter instead of this pick operator? In regards to the map, we can see that we are setting some additional flags in the stream. So map is setting the not sorted flag, and so on. And we can see, for example, the filter, which filtering out, we can change the number of the elements in the stream, is setting the stream flag not sized. And because of that, if we use some operator, that, for example, pick or the map, which is not changing the number of the elements, it will be optimized out when we use the count operator. And if we use the filter operator, it will not be optimized out because the stream can have the different number of the elements. And to know that, to learn more about that, it's good to go into the JDK code and see that this is the part from the code from the count operator, and this is from the additional code for the streams. This is not the one thing that can be optimized, because on the other hand, if we have some streams, especially parallel streams, it can be calculated by stream that the loading all data from the input stream into memory would be the best performance optimization to run the stream faster, which can end with the out of memory exception, for example. And we can see on the screen that we have this question on the JDK list, where Victor Klank, which is one of the author of GATRs, of the stream GATRs, what we will be talking in a few minutes, is giving an example how it runs and how it could behave. So this is important to be aware that if we use especially parallel streams, we can end up with problems like that. And some parts of these issues, especially one part, which is parallel streams, are solved by stream gatherers. So with Java 24 and previously with Java 22 and 23 in version previous, so preview in 22, second preview in 23, and general availability in 24. We have new addition after the 11 years of having streams in the Java, the new addition to Java API, which are stream gatherers, which is important. The version from the Java 24 and 22 and 23 is not changed. It's the same API, same code, and so on. It only was previewed 3 times to make sure that it gathers proper feedback, and in the end, it works pretty well. And what is giving us these stream gatherers? They are giving us opportunity to write our custom intermediate operators. So in the end, we now, with Java 24, can create custom intermediate operations in the same way that we are able to create custom terminal operation using collector interface. The most important interface that we have in the stream gatherers and Java 24, we have the interface gatherer, and again, we have these mystic letters, TAR, which means in the end input, mutable state, and output. So we have what is going into this our gatherer, what is the state of this gatherer, because we now have the state. We can build a stateful or stateless gatherers, and what will output from this gatherer. And yeah, so we have this map concurrent, the most important gatherer that we have from the gatherers, which allow us to fix the parallel streams. We can see that on the left we have our code with parallel streams, so 20 jobs, parallel, it takes 2 minutes. And we have the new one. Instead of the parallel and map, we have gather map concurrent. And we can see it runs in 20 minutes. In 1 second, 20 jobs. So seems fixed. Let's go back into the code. To parallel. Let's remove the map. Gather. We have the number of the concurrency, the max concurrency, let's it be 20 for now, and the mapper was parallel API action, this one. So we have our getter. We'll run it again for the 17 job. And we can see that it runs for the 1 second. But we can run it with more numbers, with more concurrency. Let's, for example, run it with 100 jobs, and concurrency will be set to 100 to the number of our jobs. And do you think how much it will take to run those 100 jobs while guessing? We can see that it works, and it takes 1.6 seconds. So we have the 1 second to run every single one of the job, and more than half a second to cooperate with all jobs to make sure that it happens. And why it is possible this way? In the end and underneath, instead of the normal threads, we are using the virtual threads, which are lighter, and we can run more of them in our applications. The virtual threads have different issues, but more or less it is something that we can use right now to make sure that our streams are working, parallel streams are working as expected. So we can make many jobs using getterers and map concurrent, and honestly I like it a lot. So if you have a chance to bump your Java code from Java 8, hopefully nobody is using Java 8 still. Anybody? Java 11? 17? Okay, a couple of hands. 21? Okay, another couple of hands. And 24 or 25? Oh yeah, there. I am amazed. Today we have the 20th of September, and Java 25 was released 4 days ago. So we have the guys that are using the Java 25 in production. Another question, or not in production yet? Okay, still it's good to have the Java 25 running. And again, examples. Let's go back to the code. So we not only can use these included batteries with getters that are included by the authors. So we have the map concurrent, we have window sliding, we have windows fixed, fault, and the last one I forgot the name right now. But we can write our own. And the most important thing is that it's pretty simple. So for example, we can recreate the map operator using the getter. So we have the word stream map and the function. And we can create our custom getter to map to work the same way that it works with from the normal library. And it's looking pretty easy. So we have the getter of sequential. So we want to make sure that this getter will be running sequential only. We have state. For the mapping, we don't want any state, so using the new Java new way of describing the variables will describe it as a underscore. The current element, sync, so something that will go. Sync is the next step in the getter, so that next step of the pipeline. And simple code that will push this element to be applied by function that we passed to it and push it down to the next step. And if we run it, we can see that it's working the same. But it looks pretty naive, this example, because it is pretty simple. The nice thing is that some elements that were hard to do with only collectors or just with streams are now easier to do with gatherers. So for example, we would like to distinct those words by its length. So in the end, we would like to have only the words, only single word of each length. So for example, we have the level and radar. So we will only have the level, then none, then other words that have different length. And if we want to do it using the only streams, so Java 27, 21, or 8, we would need to map them to new string, to new object that has custom equals and hash code, make distinct operation on this stream, and again get this value from this custom object, and then we have it working. And if we have different situation, maybe distinct by some other field and so on, we need to write another record, another object that will wrap it up and so on. It's not looking nice and not so good. But with gatherers, we can write a custom gather that will allow us to do the same. So instead of this mapping these strings into the custom code, we can use our custom gather, and we have the gather called distinct by, where we pass the method, and make it to list. And let's see how it works. We can see that it works exactly the same as the code from the previous example. And we have the gatherer. So again, we have that this is sequential gatherer. We have the state, it will be hash set, and we have the method that is the body of our gatherer. And we can see that we are passing to it the state element and our sync downstream. And what we are doing? We are checking if the next step in the pipeline is not rejecting our data. If it's not rejecting our data, we are going to add this element, or at least add the result of this method, distinct method, to this state, so our hash map. And if we add it correctly, we are pushing it downstream. Otherwise, we are not pushing it downstream. So we'll filter them by this utility function. Let's see how it works. I will run it in debug mode. And we can see that we have the first word level. The downstream is not rejecting, and we try to add it to the state. We are added it to the state. The size is 5 of the level. So we are pushing it to the next element of the pipeline. The same, we have another word, radar. We are trying to add it to the state, and we have the number 5, so length 5 in the hash map, so we are not adding it and we don't pushing it further. And next word is none. It has 4 letters, so now we have the 4 and 5, and we are pushing it to the next step of the pipeline, and so on and so on. This way it works pretty well. And what I said previously about this identity function and characteristics, in regards to the gatherers, we have a bit more, we are handling it a bit differently. So instead of defining the characteristic, we are using utility function. For example, we have this off sequential and so on. So if I want to create the parallel gatherer, I will use off. So off sequential is creating is adding the correct characteristics for the gatherers. For example, sequential one, off is adding information that it can be parallelized. And in the end, we also can be sure that the gatherers can be greedy or not. And the same way, we can add this information for the definition of the gatherer. So we have the method of greedy or of. It's for the integrator, so the method that is eating our data. And let's look at the window one example. The second, I think that's the next to the map concurrent, window sliding is the second, more for me at least, most important gatherer that is included in the new Java. So let's assume that we want to have the information about the anomalies from the data. We have some reading of the timestamp and temperatures. It is for the every 15 minutes. And we would like to find the anomalies. So anomaly for us will be when the temperature from the previous reading will differ more than 5 degrees from the next reading. If we want to do it in the normal code or for loop, we need to store the previous value, next value, and so on. And having the gatherers and streams, we have simple window sliding gatherer, and then we can use this window having 2 elements, because window size is 2, to grab the next temperature and the previous temperature. So if we run it, we can see that we have 2 anomalies between the 1050 and 1030, 21 degrees and 27 degrees, and the second one 12 and 1215. So it's worked pretty nice, and it's more than it's easier to read the stream code with gatherers than a couple of for loops. And the question is, of course, how we can learn more about gatherers, how we can get to know how to use it, and so on. The most important, the most easy, and the most fun in the end way is to practice by building your own. So for example, we can write our own map, our own filter, and so on. We can rewrite all gatherers, or intermediate operations that are already available in the Java using gatherers. It is a great idea to learn how to write gatherers. And the second way is to see how other guys were writing additional gatherers. So for example, we have the 2 libraries. One is more gatherers, and the second one is gatherers for J. What's important, those libraries are not new. So it's not like we have the Java 24 for the last 6 months and they were created 6 months ago. Those libraries mostly exist for at least, we have 24, 25, for at least 2 years. So from the first version of the gatherers, so preview, they popped out and they are more or less badly tested. So if you have possibility to use code that is written by somebody, why not? These have some problems using the code of the other people, but we don't have to write it by hand. And let's talk a bit about best practices in regards to the gatherers and streams. The most important thing is to format it nicely. Sorry, but if we have the stream in the one line, even if we have nice 27-inch monitors, it is hard to read. We can see that this first one, stream, it's the same stream, the same definition. The first one is harder to read than the second one, because we can go line by line. And the second thing is, this way we are able to debug them easier. So see where it breaks, when it breaks. So for example, by the checked or unchecked exceptions. Also, it's good to check for nulls. because in the end, as we know, if we throw the runtime exception, for example, null pointer exception, the stream will terminate. Another good practice is to use method references instead of lambdas, because in the end, this code that is using lambdas is more optimal. Because JDK, JVM can optimize this code. So this objects non-null will run faster, or at least can run faster than this lambda. This lambda can be translated to an anonymous method, anonymous function, and so on, which will run slower. This is the one thing. And the second thing is that, again, the method reference, so objects not null or not string empty, is easier to read than this lambda. Another thing is that we should use the correct order of operations. So, for example, we should filter data first. We know that the streams are lazy, so if we filter out the data in the previous steps, then in the next steps we'll have less to worry about. And in this example, we can see that first stream will make all string uppercase, every single stream, no matter how much strings it will have. And then it will filter by length, which is wasting the CPU. And the second one will first filter by length, so we'll only have in the next step in the map, we only have the strings that have the length more than 5 letters. And of course, in the end, if you have to decide, write streams, write loop, there are some situations that the loop is still better. So, for example, we can have multiple operations per step. We can process 2 lists at once in one for loop, for example. In case of the streams, we need to make them into the one stream and process them in the one stream. It will be more problematic than running simple for loop. So sometimes that loop is better, and sometimes it could be faster. And this is all from me for now about the stream.rs. If you have any question, this is a perfect time to ask. And if we have later questions, again, my social media and link to the page is on the screen. So, any questions? Okay, we have one.
Regarding that example with checked exception, have you tried to use it called try off from waiver library? And if so, what do you think about it? Is it good practice, bad practice?
From my perspective, I didn't have opportunity, didn't need to use the waiver library in the end. It's great, and but didn't need to use it. But on the other hand, if we have something like that, it is well done, battle tested library that is with us for the last at least 8 or 9 years or more, something like that. It was called differently in the previous times. It's, yes, exactly, Java Skrang, then renamed. And from my perspective, it is if it is doing the job for you, then use it, because the mental overhead of handling the stuff that we have of remembers about handling this exception, using this library and so on, if it will be easier to you to understand the code with waiver, it's better for you and better for the all guys that will work with you on the same code. And if you will use this code, you will use this library, probably I will be happy if I will have to work with your code in the future. Okay, so we have no more questions, so thank you all. And again, if you want to find me, contact me on the social media or whatever. I will be here also, so if you can chat, let's chat. Thank you all.